Kia ora Year 10, this is video 2 that goes with chapter 11 of Gamma. This one's going to look at how we multiply fractions. So I'm going to do just 4 examples in this video, but I want to show you 2 different ways to attack harder ones like question 4 in here. So remember back when we looked at how we multiply fractions with just numbers, we did this. So suppose I had 2/3 of 17 over, I don't know, something stupid like 31. Let's do that one. What do? Well, we multiply the numerator and we multiply the denominator. So we get 34 over 93. Then we look and we see if we can simplify. And in this case, we can't simplify. So we're done. That's the end of that one. Now let's just think about ones where sometimes we can simplify before we get to the final answer, because that's a strategy that works really well with algebraic fractions as well. Suppose we had 2/5 times 3/8. Now we could always multiply the numerator and the denominator and we'd get 6 over 40. And then we'd simplify that and say, well, there's a common factor here of 2, so we get 3 over 20. That's fine when the numbers are quite small, but when they get bigger, that can be pretty painful. So it's a good idea to get used to this strategy back when we're dealing with easy ones. If we look at the 2 and the 8, we can see that there's a common factor there of 2. So I guess the slightly more advanced is not the right word, but kind of more fluent with fractions and with algebra way to deal with it is to start doing the simplifying when you see it. Right, so here we've got 2 over 8, which we can change to 1/4, and that gets me straight to my answer now of 3 over 20. The only big caveat that I would put in here is that often it's fine to get the hang of it when you're working on multiplication problems, right? Because we know that we can simplify this. The reason we can do this is the same as 2 times 3 over 8 times 5, right? So then we could change that to be like this. The problem with doing this is that when we go back to add fractions, we have to remember that we can't do anything crazy like that here. We can't go linking up that 2 and that 8. They mean completely different things. So when we're adding fractions, the key rule to remember is find your common denominator. Okay, so here it would be 40, and we'd say 2 8s, 5 what's a 40? 5 8s, so 2 8s are 16, plus, right, 8 what's a 40? 8 5s are 40, 3 5s are 15. Okay, so I'm quite keen for you to start learning this method, but only if it doesn't mean you start to muck up your simple fraction addition ones. Alright, now let's get back into the 4 examples that I actually wanted to talk about instead of getting sidetracked. So when we're multiplying algebraic fractions, they work in exactly the same way as our ordinary fractions. So question 1, we've got 3a over b times 4a over b. So I multiply the numerator and I get 12a squared, and I multiply the denominator and I get b squared. There's nothing more I can do here, right? We're finished. Next one, 4c over d times y over 2d squared. Multiply the top, it'll be 4cy, and multiply the denominator, and we get 2d to the power of 3, right? There's an invisible 1 here. Now if you're watching this and you haven't done all the work from last term yet, you're probably going to be finding this a little bit too fast, so just make sure you go back and catch up on that and email me if you need to. Here we're not finished because the 4 and the 2 can be simplified as we saw in video 1. So that gives me 2cy over d cubed, and that's my final answer, so that's not finished. Alright, number 3. We're starting to have some powers. So x squared y over 4 times 12x over y cubed. Right, so multiply the top line, the numerators, and we get 12x cubed y. Remember, that's x to the power of 1. And so we take the ones with the same base and we can just add the powers. And in the denominator we get 4y cubed. Now we've got a bit of simplifying to do here. The 12 divided by the 4 gives me 3. I've got x cubed here and no x's anywhere else. But here with the y's I've got y to the power of 1 and y to the power of 3. So I'm going to end up with y squared sitting in the denominator. Okay, now if you're not happy with that, go back and watch video 1 again, and make sure you've done Gamma 1101, because it's got lots of great practice with that skill. So that's that one done. Okay, now on to number 4, and this is where I'm going to use both methods of simplifying. So we've got AB squared over 2c times 12c over AD. So I guess the starting out way is just to chuck everything in together, right? Multiply the numerators and we get 12a b squared c. Multiply the denominators and we get 2a c d. Now I've written that in alphabetical order because I'm kind of uptight like that, but if you don't do that, that's fine. The order doesn't matter. It's just a nice habit that makes you not forget to look at variables. So in here we've got the 12 and the 2, so we're going to have a 6 for a coefficient here. Here, a divided by a simplifies, c divided by c simplifies. So I'm left with 6 bd squared over d. So that's as far as we can take that one. Now I want to show you a second way to do this problem, which is where I simplify before I do all of the multiplication. So let's just have a look at how else I could think about that. Well, I could rewrite it like this. 12a, no, let's not do it like that. Let's do it like this. 12c over 2c times ab squared over ad. And I'm not going to ever do that, but when I'm doing my very first one, it's a nice way to realize what's going on. Because the order of multiplication doesn't matter, then I can rearrange the order and more easily see what can be simplified, right? So the 12 over the 2 gives me 6. C divided by C gives me 1. A divided by A gives me 1. And so I'm left with just 6 BD squared over D. But as I said, we don't usually go through all of the palaver of writing that out like that. Instead, we do it like this. We've got AB squared over 2C times 12C over AD. Well, we will look first at the numbers and we see 12 divided by 2 gives me 6. So we write 6 like that. Then we work alphabetically. We've got an A here and an A here. A divided by A is 1. C divided by C is 1. So that gets me to 6 BD squared over D. The only thing that I'd say that I really don't like about this method is it just looks so messy, right? But it's pretty efficient. So this is one of those rare times where I'm going to say, as long as you've shown me you're working, that's fine. But your working might look like this. But always start out with cleanly writing out the expression, as I did here. All right, thanks for watching. That should get you through 1102. I'll be back with a video on 1103 shortly.